So in this video, we'll look at more problems related to the logarithmic differentiations. And let's look at the current problem. Now, f of x equals sine x to the power x. And I would like to emphasize that the power is a variable x. And sometimes even more complicated examples can occur where the power actually contains a function of x. So in general, I'm saying that the power is not a constant now. And so I would like to emphasize that please don't use the power rule here. I mean, if you try to differentiate these functions, so please don't think you can just pull out the exponent x and the power is decreased by 1 like this. It's completely wrong. The power rule cannot be applied when the power actually contains a function of x, which is not a constant, definitely. So the proper way to deal with this problem is that we can let y be sine x to the power x first. And as a way to do the implicit differentiations, we can apply ln to both ends. So ln y equals ln of sine x to the power x. And there's something you need to know. The fact is that ln has a very special property where the b as the exponent can be pulled out of the ln function like this. And we can use this fact here. So it means that the exponent can be pulled out x times ln of sine x now. And I hope at this stage you can see why it is very helpful for us to use the ln at this stage, because after applying the ln, the right hand side is a product of two functions, x times ln of sine x, right? And you are able to differentiate this function, obviously. And let's do an implicit differentiation here for both ends. So we'll apply the differentiation now for both left hand side and right hand side. For the left hand side is ln y. Ln y becomes 1 over y first, times y prime, right? And because ln y becomes 1 over y when you do differentiation with respect to y. However, we are doing differentiation with respect to x, so there's a chain rule term coming out, which is the dy dx term. And the right hand side is going to be the derivative of the product of two functions. So I can actually apply the product rule. Ln of sine x is the second term of here, and plus x times the derivative of ln of sine x. So please think about how to differentiate this function. It becomes 1 over sine x times cosine x. I'm using a chain rule here. And this problem is almost done. So because I can actually multiply y to the right hand side, you see, there's a 1 over y here. I can apply it to the right hand side by multiplication of y. So y is multiplied to the whole thing, ln of sine x plus x times cosine x over sine x. So please see what I'm doing here. I'm grouping all the terms as a single fraction. And basically, that's the final answer. Obviously, it would be quite nice that you can write the answer down in terms of x only. So y is actually the same as sine x to the power x times ln of sine x plus x times cosine x divided by sine x. And that's the final answer to this problem. We can actually do one more. So please look at the current problem. F of x equals x to the power x squared plus 1. And please look at exponents now, which is a function of x basically. And the same as the trick that I provided in the last problem, you write it as y equals x to the power x squared plus 1. And I can apply ln to both ends. And exponents can be pulled out, x squared plus 1 times ln x. And we can differentiate both sides, differentiate with respect to x. So it becomes 1 over y times y prime in the left hand side. The right hand side is the product of two things because we have to apply the product rule, like u prime v plus uv prime. So u prime is 2x. I'm differentiating x squared plus 1. V is ln x plus u is x squared plus 1, and v prime is 1 over x. So basically at this stage it's almost done. We just need to multiply this y term to the right hand side, so it becomes y open bracket 2x times ln x plus as a single fraction x squared plus 1 divided by x. And of course it would be nice if you replace the expression of y as a function of x. So x to the power square plus 1, it is y, times the remaining things inside the big brackets. So that's the final answer to this problem.